Hello, welcome to this session. Thanks for making the time to watch this video. My name is Shian Nafti. I'm a Google authorized trainer. I travel around the world delivering training to Google's clients and partners. In today's session, we're going to explore Istio. Istio is a service mesh that enables us to have better control over the communication between services running in a cluster. In this session, we're going to explore the Istio Mesh Expansion configuration. In this configuration, we're able to deploy microservices within Kubernetes clusters as well as virtual machines, and use the service mesh to control how services across those two platforms communicate. We're going to start off by downloading and extracting Istio. The version of Istio we're going to download is version 1.4.0. Having downloaded Istio, we're going to proceed and enable access to the services we're going to use in this demo on the Google Cloud Platform. One of the most important services we need is the Kubernetes engine service, as well as the ability to create virtual machines. Having enabled API access, we're going to create a network for our compute engine resources. Having created the custom mode network, we're going to proceed and create a subnet for this network, specifying the range of IP addresses that will be made available within the US Central 1 region. Let's visit the Google Cloud Web Console to explore the configuration we've just performed. To do this, we're going to navigate to the networking section, select VPC Network and VPC Networks. You can see here the network we just created, the Mesh Expansion GCE Net. Having created the network, we created a subnet within that network. The subnet was created for the US Central 1 region. We also specified a range of IP addresses available for use within that region. Let's click on the network. Here we can see the name of the network, the routing mode that was selected, and we have confirmation of the subnet configuration. Let's return to our Cloud Shell console. Having created the network, we're now in a position to create our Kubernetes cluster. Let's create our Kubernetes cluster in the US Central 1 region. We're going to use a machine type N1 Standard 4. The cluster will be a 2-node cluster. With the cluster configured, we're going to proceed and switch context to this cluster. Next, we're going to retrieve its credentials. And using the credentials, we're going to grant admin access to this cluster to the current logged in user. Let's explore the cluster we've just created on the Google Cloud Web Console. To do this, we're going to navigate to Kubernetes Engine, Clusters. You can see here a cluster hipster-exp located in the US Central 1A zone. The cluster size is 2. This corresponds to 8 virtual CPUs and 30 gigabytes of memory. Let's explore the configuration further. The cluster has been configured using the latest supported version of Kubernetes. We have displayed an endpoint for the API server of the cluster. We also have confirmation of the network the cluster is deployed against. Here we can see the range of IP addresses that will be allocated to pods running within this cluster and the range of IP addresses for services in the cluster. And at the bottom, we have confirmation of the default pool. The pool has 2 nodes and auto-scaling isn't enabled for this cluster. We can also view the nodes of the cluster by selecting the Nodes tab at the top. Here you can see the 2 nodes. They are both ready, along with the configuration for each node. Let's return to our Cloud Shell console. In the next step, step number 5, we're going to install the service mesh into this cluster. Let's start off by changing to the directory where Istio was downloaded and extracted. Next, we're going to apply the configuration for the custom resource definitions. Having applied the configuration for the custom resource definitions, we're going to add the configuration for the Istio system namespace into a custom YAML file, which we'll apply later. Next, we're going to use the Helm template tool in order to customize the YAML file further by setting the option for mesh expansion. With the custom YAML file created, we're now going to apply it against the cluster in order to configure Istio. Let's return to the web console and explore the configuration we've just performed. To do that, we're going to navigate to the Workloads tab. You can see here that we have a number of deployments and one job configured against the Istio system namespace. Let's select one of these deployments to view the configuration. Displayed at the top is a dashboard for the pilot CPU, memory, and disk utilization. Additional information on the deployment is also displayed. Here we have the cluster, the namespace, labels. We can access the logs as well easily. Further down, we can see the pod that was provisioned using this deployment. Let's click on this pod. You can see that the pod has 2 containers. One of the container is running the application and the second container is the sidecar proxy. We can also see the service that's used to expose this pod. The service is of the type cluster IP, which means that it's accessible within the cluster using this IP address. Let's move on to the next tab, the Services and Ingress tab. On this tab, we can see the services for all of the deployments, as well as the Istio Ingress Gateway service, which is of the type load balancer. This service enables access from outside of the cluster. Let's return to our Cloud Shell console. Having created our Kubernetes cluster and configured the service mesh, we're now going to proceed and create our compute engine resource, that is our virtual machine. We're going to do that in step number 6. But before we create our virtual machine, we're going to create a couple of firewall rules. The first firewall rule enables us to be able to access the virtual machine and perform some configuration tasks. Having created the first firewall rule, we're going to create a second firewall rule. This second firewall rule enables the services that are running within the virtual machine to be accessible from within the Kubernetes cluster. You can see from the configuration of the firewall rule that was specifying a source range. The source range corresponds to the IP addresses that will be allocated to pods within the cluster. And the target tags relates to a tag that will be allocated to the virtual machine. This firewall rule allows TCP traffic on port 3550. Port 3550 is the port that will be used by the service running within the virtual machine. Having created the firewall rules, we're now going to create our compute engine instance. The compute engine instance of virtual machine will be created in the US Central 1A zone. That's the same zone as our Kubernetes cluster. We're going to use the network and the subnets we created earlier. You can also see that we're specifying a tag on the compute engine instance, Istio-GCE, and this tag corresponds to the tag that was associated with the firewall rule. In so doing, the firewall rule we created earlier that enables resources deployed within the Kubernetes cluster to access services running in the virtual machine will be applied to this compute engine instance. Our virtual machine has now been created. We have confirmation of the machine type, the internal and external IP addresses. We're now going to move on to the next step, where we're going to create the configuration files required to create a remote instance of Istio within the compute engine virtual machine, as well as configure the microservice that will be running in the virtual machine. To do this, we're going to move on to step number 7. The first configuration file we're going to create is a configuration file called cluster.env. This configuration file is for Istio, and it specifies the authentication method, the range of IP addresses that will be assigned to services running within the cluster, as well as the Istio inbound port. In order to enable mutual TLS across the cluster and the virtual machine, we need access to the root certificate configuration files within the virtual machine. In this step, we're going to extract the certificates and keys that were configured for the root certificate authority within the Kubernetes cluster into files which will be copied across into the VM and used to configure mutual TLS. Next, we're going to configure a bash script. The bash script is called configure-vm.sh. There are 2 variables we're going to customize within this bash script. The first variable is the IP address of the Istio ingress gateway within the cluster, and the second environment variable is for the Istio version. You can see in the script the IP address of the ingress gateway, as well as the Istio version, which is version 1.4.0. Having created these configuration files, we're now going to copy the configuration files into the virtual machine. Before we move on to the next step, let's take a look at the files we've just generated using the Cloud Shell editor. To do this, I'm going to switch over. Let's expand the working directory for Mesh Expansion. Within the working directory, you can see the certificate chain file, as well as the private key for the root certificate authority and the root certificate. You can also see the cluster.env file. The cluster.env file specifies the authentication method, the range of IP addresses allocated to services running within the cluster, that's Istio services, and the Istio inbound port. You can also see here the configure-vm.sh script. This is the script that will be executed within the VM to configure Istio as well as the service running within the VM. Let's take a look at this script. You can see at the top, the version of Istio is defined as well as the gateway IP address of the Kubernetes cluster running the control plane. Next, we have a set of instructions for installing Docker. We also have configuration that enables access to the control plane component from within the virtual machine. Here, we're modifying the host file and setting the gateway IP address as the endpoint for the control plane components. In the next step, we're downloading the remote version of Istio from a cloud storage bucket. Having downloaded the remote version of Istio, we then install it. You can see here some additional configuration required for making the certificates that we copied from the cluster accessible within the virtual machine. All of the certificates and keys are copied into the /etc/certs directory. The Istio configuration file or environment variable configuration file is copied into the var lib istio envoy directory. Ownership of both of these directories is set to istio.proxy. So we're granting the Istio proxy the ability to read these files. There is some additional configuration required where symbolic links need to be set. Once all of this configuration is performed, we are in a position to start Istio within the remote virtual machine. Once Istio is running within the virtual machine, we're in a position to start the product catalog service as a Docker image within the virtual machine. You can see here the port 3550. You may recall we created a firewall rule that allows traffic, TCP traffic on this port. And here you can see the version of the product catalog service. Let's return to our Cloud Shell console. In the next step, step number 8, we're going to expand the mesh. Expanding the mesh involves logging into the virtual machine and executing the compute-vm.sh script we explored earlier. Before configuring the VM, let's register the microservice that is running within the virtual machine. Here, we're using the istioctl command, register, specifying the name of the service. This is the IP address of the virtual machine and the protocol and port. Let's verify this by getting the endpoint of the product catalog service. The endpoint configuration was returned. That's the IP address of the virtual machine. The protocol is TCP and the port is 3550. In the next step, we're going to configure a service entry YAML file that enables the Kubernetes cluster, in other words, the Istio control plane components, to be able to forward requests to the service that is running remotely within the virtual machine. In the configuration file, we specify the host for the product page catalog service as product catalog service, that's the name of the service, .vm pod.sbc.cluster.local. We then specified additional configurations such as the protocol, the port, and the destination, the endpoint, which is the IP address of the cluster. In step number 9, we're going to log into the virtual machine and execute the compute-vm.sh script. To do that, we're going to SSH into the virtual machine. The virtual machine is running in the US Central 1A zone. We're going to change the permission of the script to make it executable. Having made it executable, we're going to execute the script. Let's verify that the product catalog service is running. You can see that the product catalog service was created 23 seconds ago and appears to be running. In the final step, step number 10, we're going to deploy the remaining microservices into the Kubernetes cluster. Let's start off by labeling the default namespace for automatic Istio sidecar proxy injection. Having labeled the namespace, let's deploy the microservices by applying the configuration for the microservices in the hipster shop-gke working directory. You can see here confirmation that a gateway was created for the front-end microservices to enable access to the application. We had virtual services defined in order to specify the path to the application, to the front-end microservice. A couple of service entry configurations were applied for the Google APIs egress and Google metadata egress. Finally, we have a set of deployments and services that correspond to the microservices running within this cluster. Let's navigate to the Google Cloud Web Console and explore the microservices we've just configured. On the Google Cloud Web Console, we're going to navigate to the Compute section, Kubernetes Engine, and select Workloads. Let's filter to the default namespace. Here you can see all of the deployments that were configured for the microservices. The status is green. All of these deployments have a corresponding pod running. If you click on any of the deployments, you would see a dashboard that allows you to visualize CPU memory and disk utilization, as well as some additional configuration information. Let's select the pod that was created from this deployment. If we scroll down to the configuration of the pod, you would see that the pods all have an Istio proxy. This is because we label the default namespace for sidecar injection. That's the namespace where all of the services were deployed. Let's take a look at the Services and Ingress tab. In the Services and Ingress tab, we can see a number of services of the type cluster IP. The cluster IP services are accessible within the cluster. You can also see here a service of the type load balancer. That's the Istio Ingress gateway. You may recall we configured a gateway as well as a virtual service. The virtual service defines a URL path to the front-end microservice, which in this instance is the front-end service. Using the gateway and the virtual service configuration, we're able to navigate to the front-end microservice from this IP address. And here you can see the application running. Let's go ahead and make some purchases. We're going to purchase the vintage record player. Let's also purchase the film camera. That looks enough. Let's place our order. And everything appears to have been successfully processed. This completes the Mesh Expansion demo. Thanks for making the time to watch this demo. Have a nice day.